In example 1, we want to solve the linear systems using linear combinations, and we have a few to do here. We've got A through F, but some of these look like they're almost set up right for us. So let's look at A, and we're going to combine these two or add them together. What we're looking for is exactly this right here. We're looking for one term, in this case it's 4x, to be exactly the opposite of another term, and we have a negative 4x here. If we have that situation, then it's time to add those together. So 4x minus 4x is 0, and 2y and 5y is 7y. I'm not even going to write that 0 down because 0 plus 7y is just 7y. We need to add the 12 and the 2. So it's also important that actually the equal signs line up and that like terms are right above each other, because you would only want to add the 2y and the 5y here. You wouldn't want to make some mistake with the 2y and the 2 or something like that. But this one's already set up for us, so we can just divide by 7, and we find y to be 2 here. We can use either one of the equations to find x. I think I'll use the top one. So we're going to have 4x plus 2y, but we think y here is 2, so we're just going to use this top one, replace the y with 2. And we've got 4x plus 4 is equal to 12. Subtract 4, 4x is equal to 8, divide by 4, and we find x to be 2. So the solution to this one we think is 2, 2. Now we will always want to check our work here, and we just used this equation last, so let's use the other one. Negative 4 times x, we think that's 2, and also 2 for y. So we're going to have 5 times 2 is equal to 2. We've got negative 8. 5 times 2 is 10, and that should be equal to 2. Negative 8 plus 10 is 2, and so this one checks out. Let's work with this one here on the right hand side. Even though we have 2 and negative 2 here, those are opposite terms, it's not going to work out well for us, because when we put these together we're going to have a 9x and a 6y, and we want one of the variables to go away, like this situation here. If we try to adjust each one of these for the term with x in it, we're going to wind up having to multiply each one by a number, so that's going to be a little bit more difficult. But what I'm seeing right now is this 3y and this 3y. I just want one of them to be opposite, so I think I'm going to multiply this whole equation by negative 1. I'm going to write this first one down here. 4x plus 3y is equal to 2, so that's going to be this one. Same thing, we didn't do anything to it. Now we're going to multiply every term by negative 1 here. So that's negative 5x, negative 3y, and the opposite of negative 2, of course, is 2. So our adjusted equation will go right below. When we have one term exactly opposite of the other, it's time to combine them. So we have 4x minus 5x, which is negative x. 3y minus 3y is 0, and 2 plus 2 is 4. If we divide or multiply by negative 1 on each side here, we find x to be negative 4. Let's choose the first equation. It really doesn't matter which one you choose, but let's just do the first one for grins. And to find y, we're just going to replace x with negative 4 and see what we get. So we've got negative 16 plus 3y is equal to 2. We'll add 16. We have 3y then is equal to 18. And then we'll divide by 3, and we find y to be 6. So we think the solution to this one is negative 4, 6. Let's check it. So for the check, we just used this one. We're going to use the one we didn't use last. So that's 5x, or 5 times negative 4, plus 3y, or 3 times 6. We're just substituting those values in. So we've got negative 20 plus 18 is equal to negative 2. Negative 20 plus 18 is negative 2. And this one checks. We are good to go. We have a few more to work here, so let's try C on. C, it seems like things are not lined up very well for us. If you look at the top one, we see that there's the x term, the y term, an equal sign, and then the constant. Here we have the y term, the equal sign, the x term, and then the constant. We really want this x term to be over on the left. We can't just move it, but what we can do is we can do the same thing to each side of the equation, and that's subtract 3x in this case. I'm going to write the first one down just as it is. So there's the first one. And then we'll write the adjusted piece down here. it's important to line up your terms. So instead of writing 4y minus 3x, then we'd be switching the x's and the y's. I'm going to line that negative 3x right beneath the other x. Then we've got plus 4y is equal to 14. Remember, 3x minus 3x is 0, and that was our goal, to just get the constant. So now the x terms line up vertically, the y terms line up vertically, and also the equal sign and the constants. Also note that we don't have to do any other adjustment with this one. We've got a negative 4y and a positive 4y. That's what we're looking for, one term to be exactly opposite the other. So we're going to combine these. 8x and negative 3x is 5x. That's 0, so we've eliminated a variable. That's what combination is also called. And we've got negative 4 plus 14, which is 10. So we'll divide here by 5 and find x to be 2. Now to solve for y, we can choose either equation. So let's just do this one for grins. So let's do 4y is equal to 3 times 2 plus 14. So 4y is going to be, well, that's 6 plus 14, or 20. And then divide by 4, and we find y to be 5. All right, so we think the solution to this here is 2, 5. Let's check it with the one we didn't use previously, so that's this first one. So we've got 8 times 2 minus 4 times 5 is equal to negative 4. 16 minus 20 is equal to negative 4, and that is actually a true statement. This one checks out. Notice how the x terms here in part D line up, the y terms line up, the equal sign lines up, the constants line up, and we have 2x minus 2x right here, or 2x and negative 2x. So it is now time, we don't have to do any other adjustments, it is time to just combine those when you see one term exactly opposite of the other. So 2x and negative 2x is 0, 3y and 5y is 8y, 11 minus 13, I think that's negative 2. So we'll divide by 8 here. We get y to be negative 1/4. All the ones we did previously had integer solutions, but you can have a fraction solution. So let's see if we can work with this one, and we'll use maybe this top one to try to find x here. So it's 2x plus 3 times negative 1/4 is equal to 11. So we've got 2x minus 3/4 is equal to, and I know I'm going to have to add 3/4 here, so I'm going to change that 11 into 44 over 4. 44 divided by 4 is 11. I'm looking for this common denominator right there. So we've got add 3/4 to each side, then we're going to have 2x is equal to 47. 3 and 44 is 47 over 4. And I'm going to multiply this by 1/2. You can divide by 2, but you're going to have a complex fraction on the right. So I think it's nice and easy to do this one as 47 over 8. Holy cow. So we think our solution here is 47 over 8 comma negative 1/4. You could change this into a mixed number if you wanted to. Even a decimal would work for this one, and this one too. So if you're using your calculator, that might be the case. Let's see if this actually worked though. I have to do a little bit of fraction work, but that's okay. So for the check here, let's see, we used the top equation, so we're going to use the bottom to check. So that's negative 2 times 47 over 8, and then it's going to be plus, let's see, 5 times y, which is negative 1/4, should be negative 13. Well, if we think about this one, we know that a negative times a positive is a negative, and we've got 2 over 8, which is 1 over 4, so that's going to be 47 over 4. And this one's going to be a positive times a negative, so there's your negative sign, and that'll be 5 over 4. If we combine these, we have a common denominator, so this is negative 52 over 4 is equal to negative 13. 52 divided by 4 is the same as dividing 52 by 2 and then 2 again. So 52 divided by 2 is 26. Divided by 2 again is 13. So this one does check with these values. Again, you could list them as decimals or mixed numbers depending on who your teacher is or how you'd like to list it. We just have a couple more to do here. So we've got E and F, and it looks like we're in luck for each one of these. And I'm just taking a glance real quick, and I see a 4x and a negative 4x and a negative 6x and a 6x, so no adjustment is needed. We'll just work with one, I guess, at a time. So we're going to add these two together and get 0. Then 8y and 2y is 10y. And 20 minus 30 is negative 10. So if we divide by 10 here, we get y to be negative 1. Either one you can choose to find x. Let's just do the first one. So we've got 4x plus 8 times y, which is negative 1, is equal to 20. 4x minus 8 is equal to 20. We'll add 8. And 4x is equal to 28. Divide by 4, and we find x to be 7 for this one. So we believe the answer is 7, negative 1. Always a good idea to check your work. We use this one here, so we're going to use the other one to check. 7 is going to go in for x. Negative 1 is going to go in for y. That should be negative 30. Let's see if it is. So we've got negative 28 minus 2 is equal to negative 30. These are two negative numbers, so you can add them. 28 and 2 is 30, and it's just negative. So we've got negative 30 there, and that does check. This last one, we've got negative 6x and 6x, which is 0. 5y and 4y is 9y. 1 minus 10 is negative 9, so we divide by 9 here, and for this one we find y to be negative 1 also. Let's see if x is 7 like the last one. I don't think it's going to be, but we'll see. Let's use the first equation, negative 6x plus 5 times y, which is negative 1. It's equal to 1. So we've got negative 5 here is equal to 1. We'll add 5. Negative 6x is equal to 6. Divide by negative 6x is negative 1. So it didn't turn out to be 7. Alright, we've got negative 1 for our solution. We just used this one, so we're going to use the other one to check. So we've got 6 times x, which is negative 1, plus 4 times y, which is negative 1. Hopefully that's negative 10. And voila, it is negative 10, so this one is checked.